MCMC stands for Markov chain Monte Carlo. The Monte Carlo part comes from the simulation of Markov chains. Markov chains have been around for ages. Monte Carlo, it comes from Monte Carlo, the place in Italy, I believe, where they have the rich casinos and stuff.
It's its own country.
Yeah, that's what I said.
It's its own.
Oh, Monte Carlo is its own country. Oh, okay.
But isn't Monte Carlo in Italy?
It's not an entity.
No, that's Andorra. It could be in France.
Entire concept of Markov chain is based on the idea of Markov principle and transition probabilities. So if you have a state space, for instance, states 1, 2, 3, you can go from state 1 to state 2. You can go from state 2 to state 3. You can go from state 3 to state 1. You can go back from 2 to 1. That is a simple Markov chain. So I could create something called P. P is the transition matrix for between the states, which we also call it as the stochastic matrix. So I can go from 1 to 2. I can't go from 1 to 3. So 1 to 1 is not possible. So when I get to 1, I definitely go to 2. So probability of 1. It's just an example. So 2 to 1 is possible, 2 to 3 is possible. Let's just say it's 0.8 and 2 to 3, 0.2. Yes, and 3 to 1 is possible, 3 to 2 is not possible. That's it. So that matrix is what we call a stochastic matrix. Oh, a transition matrix. There are some properties of Markov chains. We'll get to that in a second, but before that, the Markov principle. Markov principle states at any given state, the probability of moving to that state is purely determined by the previous state and not the states before, which is why we are able to come up with a transition matrix of this sort. Does that make sense? There are some conditions for convergence. What do we mean by convergence? If we keep on going in cycles, eventually P will converge to what we call a steady state distribution. There would be a column vector or a row vector, depending on how you define it, which would result in a steady state distribution. If I keep on repeating the cycle, I'll end up getting one single steady state vector. I don't want to get into the details of all that because Markov chains is a field in and of itself. So one of the conditions for that steady state to exist is being periodic and something like that. That is called a recursive state. If that happens, there is a good chance that a chain can come to this state and get stuck right there over and over and over before moving out of that state. So those are conditions. As I said, Markov chain is a field in and of itself. There is periodicity, there is ergodicity, there is recursive property, cyclic chains, acyclic chains, blah, 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 whole lot of stuff. So, the idea of Monte Carlo simulations comes from creating one such chain and simulating using that chain, hence the name Monte Carlo. Markov chain, Monte Carlo. The specific algorithm